Hello viewers, Moments question 5. We have an unknown force in the middle of the beam, which is force F. We have a 1 Newton force, which is 1 metre away from A. We have our unknown force, which is 7 metres away from A. And we have a 67 Newton force, which is 9 metres away from A. We want the whole situation to be in equilibrium, so we need to make the sum of the moments equal 0. Let's take A to be our pivot and clockwise to be the positive direction. Okay, so the sum of the moments here, we've got all of these down forces on the right as the diagram illustrates, so therefore they should be clockwise and therefore these will be positive. We've got 1 Newton times 1 metre for the first force. The unknown force F is 7 metres away, and the third force is 67 newtons and it's 9 metres away. Since B is equal to 0, it's like there's no force there at all, so we don't have to worry about B in our equation here. And we need to solve that equation for F. So at the moment we've got 1 plus 7F plus 67 times 9 is 603 equals 0. So therefore, if 1 plus 603 is 604, let's move that to the other side, and then 7 times F. So therefore, we've got F is negative 604 divided by 7, and if we calculate that, we get 86.3 newtons, and that's negative, which means the direction is the opposite of what the diagram suggests. So that's actually an up force, which is not surprising given that the other two forces are all going to cause a clockwise moment. F must therefore cause an anti-clockwise moment if we have any hope of making the sum 0. Okay, so we've got what the value of F is. Now we need to find out what that makes A. So we'll use our other condition of equilibrium. Sum of forces equals 0, and we'll say upwards is the positive direction. Okay, so our up forces are A, and we've just found F to be an up force, which is going to be 86.3 minus the down forces, which are 1 and 67. So therefore, A must be equal to 68 from those two, minus 86.3, so that's going to be negative, which means that A is going to be a down force. So A is 68 minus 86.3 is negative 18.3 newtons, so that's 18.3 newtons downwards. We were assuming that A is a support and therefore it would be an up force, but we're getting a negative answer, which means the direction is opposite. So we're actually getting our up force, which would be our support in the middle or close to the middle of the beam, and at A we've actually got a down force of 18.3 newtons. So instead of a beam scenario, it actually turns out that this is more like a seesaw scenario with down forces at each end and with a support in the middle. Okay, thanks for watching. Over and out.